Hello student, welcome to our physics discussion, that is physics in a smart way. Good. Last video we have seen the evolvement of the formula for center of mass or center, as you can say, the same thing is valid for center of gravity, except a minor difference for very large object where acceleration due to gravity changes from position to position. Their center of mass and center of gravity will be two different entities. Otherwise, mostly for your building or for, let us say, the comparatively large mass, just like a city and all that. So, if you try to uproot it, just like Lord Hanuman used to do, if you uproot a city, uproot a small hill, small mountain, so then center of mass and center of gravity will be at the same place. Otherwise, for Himalayan mountain range, Bay of Bengal, where acceleration due to gravity will be changing from position to position, then center of mass and gravity will be two different things. But that is not to be discussed today. So we do know that center of mass is a representative of the system and if I put it in a different ink to make it bold, the center of mass will be having positions x and yc, or you may say center of mass will be having its position vector, that is rc vector will be equal to xc I cap plus rc vector. We can also write down rc vector will be equal to, that is xc I cap plus yc j cap, if somebody is putting that in the form of position vector and ijk. Okay. Let us say we consider a situation, there may be three masses, there may be four masses, it's a discrete system. Number of masses doesn't matter. Still, if the positions are given to you, you can find the position of center of mass. Only difference that will make is that formula can be longer or shorter or of medium length. Depends on the number of masses. But mostly we have talked of the center of mass of the system, that the system is mostly at rest. Let us consider a situation where on the masses individually, several external forces do act. External forces, mark my words. Internal forces, they do not make any impression on the system as per the Newtons. So as a result, the masses will be accelerating. Let us say mass m1 is accelerating at a rate, that is a1, and a1 is a vector. m2 is accelerating at a rate of a2, and a2 is a vector. Similarly, m3, m4 like that. And under this situation, obviously, we must expect that center of mass must accelerate. There won't be a situation where center of mass bids goodbye to the masses and then says, you all go away. After some time, I'll go ignore. Such a situation won't exist. So if somebody tries to find the acceleration of center of mass, acceleration of center of mass, then acceleration of center of mass will be, if a student writes like this, that is sigma m into a vector by sigma m, he or she will be perfectly correct. Upon elaboration, that will be your m1 into a1 vector plus m2 into a2 vector, m2 into a2 vector plus that formula continues till the last mass is encompassed by m1 plus m2 plus the formula continues till the last mass is exhausted. Another student thinks like this. He or she can say, because center of mass is the representing of the whole system, then acceleration of the center of mass, he or she is thinking in a way that as if the whole mass is concentrated at the center of mass. As if the whole mass is concentrated at the center of mass, and you know the whole mass is nothing but sigma m, sum of all the masses. So he or she can write that is the resultant force by the total mass of the system, that is sigma m. Mark my words, R is the resultant force. And resultant force will be coming in if you add the forces individually, but mind it, they are vector addition, not a scalar addition. We are not mad or we are not so dull to treat vectors or to risk in putting the vectors as scalars. So F1, F2, F3 vectors, those are the forces acting on the masses by your, that is sigma m. Okay. 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 Now you see there is a very small difference in the process 1 and process 2, but if the data is correct and if the things are put in the proper way, then answer is to come out exactly the same. If answer doesn't come out same, then there is a serious mistake with our solution. So serious numerical mistake with our solution. So thereby we do know, my point was basically to put down the center of mass as if a just like Chief Minister or Prime Minister Modi or something like that, or a sarpanch like that, to put down central mass in a position like this. That is the central thing, though that may not exist. But if for all practical purposes, if you assume that central mass is the representative, is the position, or is the representative of the whole system, then no harm is done. Okay, let me clear the screen. And there is a rule that involves the center of mass. The rule is very important. The rule involving center of mass is like this. You better write it down as I am writing. If a system goes through a change, the cause of which is internal, centroid. When I say centroid, I mean center of mass. Or you may say center of mass or centroid will follow its original or initial. Better if you put down the words original, its original plan of motion. If a system goes through a change, the cause of which is internal, the cause of which that's an internal change, goes through a change. When we say goes through a change, basically we mean physical change. If you like it, you can make a small correction. Physical change. We are not interested in chemical changes and all that. Though the thing is valid, but at present we don't have got enough time to deal with it. So again, coming back, if a system goes through a physical change, the cause of which is internal, the center of mass will follow its original plan of motion. So when we say physical change, maybe there is a bomb, the bomb explodes, and for simplicity, we assume that bomb is exploding into equal number of parts, into identical parts, and they are moving out in all directions. When the bomb explodes, you know that is due to the release of internal energy. Nobody outside did beat the bomb or something like that. So thereby, this is a physical change. The cause of the physical change is the release of huge internal energy. So the cause is internal. Maybe Let us say I got a brick or something like that, and the brick is thrown, brick is flying in air, somebody throws it, and during the mid-flight, the brick breaks. The breaking of the brick is an internal process. Nobody has gone up to its position and hit it. So that's an internal process. Or maybe you can do a mischief that we can have two masses, M1 and M2. M1 and M2, initially we can have a spring between them. Then we compress M1 and M2 and bind them together and make the string in such a mode, in such a weak position that when you throw the two mass system, that goes nicely, but somewhere mid-air that breaks, the string snaps. So that can be taken as a physical change. The masses will be separating because the spring will be pushing M1 to the left and pushing M1 to the left and M2 to the right during the motion. And then some peculiar things will happen, which can be predicted very easily by center of mass, which can be solved. The problem can be solved very easily by center of mass. But the snapping of the string and the separation of the masses, this can be taken as an internal change. If the change of the system is internal, then center of mass will follow the original plan of motion. Center of mass will follow the original plan of motion. That means if the center of mass was at rest initially and then the change occurs, then the cause of the change internal, then center of mass says, no, I was at rest, I will be remaining at rest, that will be continuing. If the center of mass was moving with a constant velocity and the change occurs of the system, the cause of which is internal, then center of mass will be maintaining that velocity. If the center of mass was moving with some acceleration, predetermined acceleration, preconceived acceleration, then that will be following that original path. But talking like this won't be making your case clear. Next video, I'll be picking up some questions on that issue. Okay, thank you today. Today I'm a bit busy. I have to hurry up. Next class, we can be continuing with her.